So I wanted to make a video this morning about basic pharmacology and neurochemistry because it's actually quite simple and quite interesting, and it's happening literally all the time. So, the cells in the body communicate via chemical signaling. The cells in the brain are called neurons, and they communicate via chemical signaling as well. They're specialized to communicate via chemical signaling. They're arranged in a big network. Each neuron is connected to many others, and these connections are called synapses. And structurally, a synapse consists of an initial neuron and a terminal neuron. And chemicals in the initial neuron are released into the synapse, attaching to the receptor of the terminal neuron and causing some kind of effect in the terminal neuron. These effects are grouped into two major types, the first of which we've kind of already described, excitatory and inhibitory. Excitatory neurotransmission is when neurotransmission induces what's called an action potential in the terminal neuron. The action potential can be thought of as a chemical charge that builds up, and when it reaches a certain threshold, the neurotransmitters will release. The neuron will fire, as it's called. So neurotransmission, which promotes the firing and forward activity of neurons, is called excitatory neurotransmission. The other major type is inhibitory neurotransmission. Inhibitory neurotransmission is just the opposite. It decreases the action potential. So it depromotes the forward activity of a neuron. It's important to remember that these two aren't so much a binary on the cellular scale, because each neuron can be connected to many others in many ways. But the main chemical mechanisms by which these effects occur are as follows. So the first type of chemical effect a receptor ligand can have is agonist activity. Again, we've already sort of covered everything with agonist activity. Agonist activity just induces what can be thought of as excitatory neurotransmission. It activates the neuron through the receptor that it's bound to, promoting forward activity of the neuron. Antagonist activity occurs in just the opposite manner. Antagonist activity and antagonist ligands, when they bind to the receptor of a neuron, depromotes the forward activity of the neuron. Somewhere in between is partial agonists, which just promote activity a little bit. They still bind to the receptor, but they only promote activity a little bit. Then there are blockers, which bind to the receptor but cause no effect other than occupying the receptor, and induce their effects that way. Then there are also allosteric modulators, which through the way they conform and bind to the receptor, change the sensitivity of the receptor to other ligands or neurotransmitters.